Gaurav Singh, who will be speaking on static typing in Ruby3 using RBS. Wow. Gaurav is a senior software engineer with experience in Ruby, Ruby on Rails, and React.js. He is an author and has created a product for picking the right MOOC for learning and a series of video lectures. In his talk today, Gaurav will present on the main features of RBS and working examples of RBS. Please welcome Gaurav.
Good morning, everyone. So I'm going to present over here static typing in Ruby using RBS. So maybe some of you are familiar with TypeScript. So Ruby has also tried to do something on the similar lines. There has always been Sorbet by Stripe, and Ruby has tried to incorporate into main Ruby. So from the Ruby3 onwards, we have a gem called Stripe. So first of all, the agenda is about what is static typing and dynamic typing, what is the difference, why do we want to do it actually, what are the advantages, disadvantages. Then how we are going to do static type checking in Ruby, and how we are going to use RBS, how to set up a bit more detail into how RBS actually works, how we can set it up for our projects. And then there is another tool called Steep, which I'll introduce a bit about. And then using Steep, how we can run static type checking into our projects. So let's start. So first thing is like, what is this typing business actually? So if you are familiar with like Java or C++, so we generally write something like string str, but in Ruby there is no concept of defining variable type while declaring that variable, right? So when you are defining string str, you are telling the compiler that str is going to be a string type variable, and whenever you are going to assign something which is not a string type, it's going to give you error. While in the Ruby, we have dynamic typing. So what happens in the dynamic typing is that type is not assigned to the variable, type is assigned to the value. So when a value is assigned to a particular variable, then its type is determined. So here in this case, you can see name is equal to who am I, then name.class is string, right? But when I assign name equal to 5, then the name's type has changed to integer. So the type is determined at the runtime. Okay, so what are the problems with dynamic typing? Why are we, what are we talking here? So first example is a like Java code snippet you can see. So what we are going to do, we are going to pass two arguments, integer A and integer B, and then we are going to return it by summing it into the integer format, right? So what happens if I'm going to do add and pass the argument as string type, right? Like add a, comma 5. So it gives me a syntax error, but this is not possible in Ruby. Like whenever you are going to say, okay, add a, comma 5, it's going to run. And at the runtime only, it's going to give me error that implicit conversion of integer is not possible into string. So these are the issues which we face at the runtime. That's why this static type checking concept came into the picture. Now, some people would argue again that we can overcome this problem by using test cases, right? Which is right. But there are two issues with that. First is like, first we have to ensure that we are writing proper test cases for the type checking. Second is whether we are reviewing the code, that whoever has written the code is properly like address all the cases or not. And both these cases involves human intervention. Like humans have to ensure that whether these two issues have been resolved or not. So what happens in that case? Humans make mistake, and then we tend to have these runtimes error. So that's why this concept of like we have a set of rules, and in the languages like Ruby, we can define those static type checks, and then by using that, we can say like, we'll try to minimize our errors. So what are the advantages of type checking? So first is like, it has a proven use case into multiple languages like TypeScript for the JavaScript ecosystem, and the MyPy is there for Python. It's a very popular library. So it helps us eliminate lots of errors in terms of no method error, nil classes. And whenever we integrate these things, IDEs automatically start to support us for like moving to method definitions, or when we are writing the code, it gives us the error cases, like, okay, you are calling the wrong method on this class. So a bit more about what is the type checking system into our Ruby ecosystem. So type checking is not particularly new into the Ruby ecosystem. It has been there from 2009. So there was a project called Diamondback Ruby, in short it's called. So that project was there. I think it was an academic project. Then there was one more project called RDL. RDL is created by Tufts University. Then on the enterprise-sponsored project is Sorbet. And then we have RBS, which is supported by community, and Ruby is officially supporting it. So basically, what is RBS? So RBS is the type signature for the Ruby. It's a language which describes the structure of our code, how our code is structured. So if I'm writing like class A, then I have some attributes and some functions into that class. Then what is the type definitions for those classes? That metadata is provided by RBS. So RBS provides that structure. And it helps us giving the whole structure of our whole code using RBS syntax. So like we can set it up RBS easily. We just have to do gem install, and we'll get RBS. Now RBS have multiple commands like AST, annotate, list. These are commands mostly for exploration of the objects which we are going to annotate, like AST for looking at the abstract syntax tree, annotating for annotating the objects, list like all the objects which are annotated into our RBS domain right now. Over here we are mostly interested into the prototype part, because if I'm going to set up RBS into a new project, how am I going to generate the code for supporting it, right? So let's explore more bit about prototype. So RBS prototype provides 3 options, RB, RBI, and runtime. RB is when RBS parses the Ruby code structurally. So it looks at the code, it creates the AST of that Ruby code, and then tries to identify what all the types of a particular variable are, what are the methods defined into that. And RBI is so, if you have worked with Sorbet, so Sorbet generates RBI files as the metadata for the annotated code which are there with the Sorbet. So what happens is that if you want to annotate or you want to port your RBI code or generate your RBI code into your RBS code, so RBS is providing those functionality as well. So you can just provide RBI and like your RBI file name. Then we have runtime. So what happens is that many times we have code for which static analysis is not sufficient enough to generate the corresponding RBS code. Whenever we are doing like a lot of meta programming, at that point of time, the RB is not able to identify what all methods are going to attach with the instance variable. So in that case, we have to load that class into memory, and then using Ruby inspection APIs, we have to identify what all the methods are available onto that class. We'll see a bit more detail about this in the further examples. So first of all, like how does a RBS look like, right? So let's take an example over here. So we have class user, we have attribute reader name, attribute reader age, then we are just initializing this class, right? It's a pretty simple example. Now, just imagine the situation like when I'm saying my user class has name and age, right? So we are already presuming that name would be a string type and age would be most probably integer. But no one is going to stop me from doing that. I can provide both arguments as the string. And later on in my code, it will break somewhere. Then I will get to know like I provided the wrong type of arguments. So for this, if we are going to generate the RBS, so what I'm going to do is that RBS prototype RB, then provided the file name. So it's going to generate the RBS file. You can see it has generated attribute reader as a string, attribute reader integer. So the string and integer, it has not generated. When you generate your types using prototype, it's going to give you untyped only. It's not going to give you the specific types. Those types we have to generate by ourselves. So that next time when you are going to run this using your type checkers, it knows what types are actually associated with the that particular variable. So you can think of this in a sense like they want to support the gradual type checking. In a new project, we can't set up for the whole, in an existing project, we can't set up the whole type checking system at one go. So what they're trying to help us with is that they will give us enough flexibility for the newer code or the code you want to change. You can explicitly write your types, and whatever there is generated, that will support your changed code. We'll see that more about that also later. Okay, so our last example. What happens if I have provided user with the both arguments type as a string, like test user and the new user, while my user instance user class only accepts name and name as a string and integer as the age, right? So when I'm doing the type checking on this class using RBS, it's telling me that cannot pass a value of a string for the integer type. So this kind of flexibility is being provided by RBS. Okay, so we talked about that runtime thing, right? So here is the code which we have. So we have seen these. I'm presuming that many of you are familiar with the define methods, like how we do metaprogramming in the Ruby class. So I have attributes array, which has like name, age, and gender. And then dynamically, I'm attaching methods, getter and setter methods onto that receiver. So dynamic person instance will have these methods like name, or you can set the name equal to. Those kind of receivers I'm setting at the dynamic time. So when I'm going to give compile it statically using RB argument. So it doesn't give us any method related RBS code because it presumes like there are no methods. Whatever it has seen over here for RB syntax, it doesn't know that there are any methods which exist. So in that case, what we do is that we have to load that class into runtime, and then runtime will tell us like, okay, you have these methods into this class. As of now, there are no mechanism to like automatically merge the output of RB and runtime. So we have to manually generate the code and see whether this code we can use or we have to like merge it using the runtime reflection APIs. So, and you can see these untypeds are generated, right? These untypeds are generated by default. These are not generated, like it doesn't identify what type it is going to return. So when I'm going to like work on my static typing further, it's my responsibility or the developer's responsibility to define age as an integer, gender maybe as a string, and name as a string, right? So we can do that further. Okay, so let's look at some of the usages, how we can use for the type checking the RBS thing. So first example is we have a class level method which accepts an optional parameter. So to define that, if you look at the line number 11 here, so we have like class is defined there, then definition, self.greet. So for all the class methods, we can use the self in RBS code. And then for the optional parameter, we can provide a question mark. So when you provide question mark, then RBS consider it as optional parameter. And the return type of greet is string type. So after the arrow, we have defined a string. So now RBS knows like this particular function is a class level method which is going to accept an optional attribute and return type as a string. Next example. So we have an instance method for which argument types are the variable types. So name ends with name and argument, and then so for the normal functions, the definition, then function name, then like type of that attribute, and then star points that this is a variable arguments. So you can like provide multiple arguments into the method, but it should all be the string type. If you are changing, if you are doing the violation of the types for those parameters or the arguments, you will get the error. Okay, so next one. So what we have is a multiply method over here, and it has one mandatory parameter and one optional parameter, and then it returns something, right? So let's look at the example over here. So example over here is like, first example is example.new multiply, then we have provided option as Ruby. So it prints Ruby 5 times. So it supports string also, and I can provide integer also. So if I'm going to provide 4 as the argument, then it's going to return 20, right? So in this case, it's going to support multiple type of the return types and multiple type of the arguments also. So what happens in this case? So to supporting these kind of use cases, they have come up with something called union types. So if you see at the RBS code, so multiply accepts either string or integer. So the pipe operator denotes a union type. And then we have optional parameter as multiplier. So that question mark over there. And then you can see it can return either a string or an integer, which denotes again the union type for the returns also. Okay, so last in this series. So this is like we have a function called first, which takes as a string and then takes the range. So let's look at the example. So example.new first RubyConf, right? So if I haven't provided any second argument, then it returns only R. But if I say example.new first RubyConf and range 4, in that case, it gives us an array of like string variables. So what happens in that case? Let's see. So if you see for the first, we have one mandatory parameter, string val. Then this question mark range is there. The formatting of R is maybe because of VS Code, but it's like optional attribute. And then we are seeing we have an union return type, which is either a string or of array of the string, right? So for supporting the keyword arguments, you will see we have this question mark range and then its type. Earlier it was mostly like integer and then the variable name. In the keyword arguments, it's the name comes first and then its type comes. Okay, so bit about how it supports duck typing, right? So in Ruby we know like we can call any method on an object. If it supports it, then it supports it. So here we have a car, and car again has like three attributes: wheels, engine, and roof. And using for all those three attributes, we have dynamically defined the method. Then my car inherits from the car. Now what happens is that in the Ruby code, I can call mycar.new.wheels. That is a valid Ruby code, right? When I generated the RBS for this code over here, it has generated only car with the attributes. It has not defined any method using the RB. I haven't used runtime in this case, just to demonstrate if you're going to work with a gem or something when you don't have access to whole the RBS code. So in that case, so you have only car with some attributes, and then my car inherits from the car, right? So, okay, for now you can ignore this include behaves like a car. I think there has been a typo. So when I'm going to call my car equal to mycar.new.wheels, it's a valid Ruby code, it should work. But when I'm going to run it, RBS gives me an error that method wheels is not defined, right? Why is that so? Because for the car in the RBS code, it doesn't have a method wheel. So how to solve this problem? So to solve this, RBS has proposed the concept of interfaces. So using interfaces, we can say like this particular object supports these methods. So for example, my car inherits from, so my car inherits from the car, your car inherits from the car, right? So there we have multiple classes which are inheriting from the car. So if I'm going to create an interface which is like behaves like a car, and I'm going to include that into my car, so in that case, it's going to be a valid RBS code. Now it's not going to complain because it knows that wheels, engine, and roof are defined into this, right? Okay, so all the errors which we have seen as of now, they have been generated using the steep. I didn't take the name steep yet because I didn't want to confuse it. So as we have seen, RBS is only the language. It only provides us that structure to define the Ruby code's structure. It doesn't do the type checking itself. There are some options in the RBS test, you can say, using which you can test particular classes, but it doesn't provide like the, you can say, comprehensive set of options using which we can do the type checking. So Ruby team itself has developed a tool called Steep. So using Steep, we can do the type checking, right? So again, it's a simple process. You can just install the gem, and you can do steep init. So what happens when you do the steep init? It generates the steep file into the root of your project. And then we get couple of options over here for like configuring the steep. So first thing is like where all our signatures for that particular file are defined, right? So generally the convention is to define them into the sig folder. So that's why the first line is signature sig. Then check lib. This is the second option, in which we are saying when you are doing the type checking, you can go to the lib folder for doing loading the classes and doing the type checking on top. Then there might be cases for some classes we don't have all the types available as of now, or we are in the process, or we haven't generated, we haven't been able to generate it, right? So we can ignore those Ruby files. Then RBS has provided us the RBS for all the standard library classes. So whatever library we are going to use, like path name, set, or strong JSON, we can just like load it, and then RBS will know what types to assign to those things, right? So, okay. So what I have done is that I created a pull request for the Discord RB project, and for some of the files, I did it as an exercise to provide types, doing like looking into things like how it is going to behave with the well-set project, right? So you can see some of the files have 100% coverage. For those files, I have provided the types. Some of the files which have coverage into the 90s, for those files also I have tried to like make those things change. And many of the files have coverage into like 50s. In those cases, we don't have types defined properly. Those are the types have been generated by the Steep only, by the RBS only. So Steep provides us this stats in which you can say like how much cover is there for your types. The same way we do the unit test coverage and all, right? So this PR is available on the Discord. You can Discord RB, so you can check it out and give me your feedback. And if you want to contribute to it, you're most welcome. And when I'm going to run this Steep check, then it goes green. It is not going green because all the types are already assigned. It's going green because for so many of the files, I put them into the ignore list. So only for the files for which I have like been able to define the types properly, only those files I'm checking over here. So in a way, it provides us help for like doing the gradual type checking, you can say. Like you can set, you already have a project which is already running. You don't have time to like address all the issues. So what you can do there is that you can start with it, and over the period of time, one file at a time, you can address these issues. So another thing is we can use Steep into our CI/CD pipeline. So here I just put an example of how to use it into your GitHub Actions, the same way we can do in the Jenkins and all. And when I was doing the exercise with the Discord RB, so there are a few things which I observed is that like, delegates are not supported. In some cases, splat operator was giving issue, not in the functions arguments, but in the code itself, like in the functions explanation of the code. Shorthand operators were not working. For example, the first case, which is there in the red, so array.reduce true, is a valid Ruby code, but it was not working. It was giving some error. But when I changed it, then it was working fine. One big disadvantage, which as of now, which RBS have, is that there are multiple methods. You can generate the output using prototype, RB, like syntactical parsing, or the runtime parsing. But there is no way as of now to merge that code automatically. So maybe in future, like we have to build a gem, or we can extend the RBS gem itself so that we can merge the code or compare the code to see like which part to keep and which part to discard. And for many popular gems, support is not yet available. So one option to overcome this issue can be that Sorbet has a gem called Tapioca. So you can generate RBI files using the Tapioca gem. And then after Tapioca, you can, using those RBI files, you can convert the RBS file again from the RBS. So that way you can have the compatibility for the gems also.